Hey everybody, hope you're doing well. We have today another huge lesson. This chapter is just chock full of them. Today we're going to learn about the sine and cosine and tangent ratios, which means this is a part of a math called trigonometry. That's a word you've probably heard before, and you'll hear it a lot more the rest of your high school career, that is for sure. Real quick, I'm actually doing this thing outside. It's rainy, the wind's blowing, there's a little mist, so I hope you're not getting wet like I am. I'm not getting very wet, but it's kind of annoying. Hope you're not annoyed. All right, so sine, cosine, and tangent are these foundational building blocks of trigonometry, and that's what this section is all about. It has to do with right triangles. Trigonometry is not all about right triangles, but our version of it is. Sine, cosine, and tangent are ratios, and they will be given from the perspective of the angles. That part is really, really important. And the ratios will be from the perspective of the angles using the lengths of the legs. Okay. Before we start talking about the ratios, we need to make sure we understand, the perspective. The three sides of the triangle from the perspective of the angles will be either the hypotenuse, the adjacent side, adjacent means next to, like those adjacent angles, and opposite side. Okay. So from the perspective of angle A, we will have a hypotenuse, adjacent, and opposite sides. So from the perspective of angle A, which one is the hypotenuse? Well, that doesn't change. Hypotenuse is always the side that's opposite the right angle. So C is the hypotenuse. Which side is adjacent? Well, what side is next to? Well, it's either going to be C or B is next to A, but C is the hypotenuse. So what's going to be the adjacent? The one that's not the hypotenuse. B is the adjacent side. And that means that A is the opposite side. A is the side opposite the angle. That we've been talking about opposite sides for a while, but adjacent sides we haven't. So hypotenuse, adjacent, and opposite. That's from the perspective of angle A. It changes when we talk about from the perspective of angle B. Well, the hypotenuse doesn't change. C is the hypotenuse for angle B, but what is the adjacent side? Well, the sides that are next to B are C and A. Well, C is the hypotenuse, so A is the adjacent side. And then what is opposite B? Side B. This is going to be a frequent way of naming these things. We're going to use capital letters for angles and then lowercase letters for these sides. And it's also pretty typical that if we name an angle or letter, opposite will be the same letter. So opposite of big C is little c. Opposite big B is little b, etc. Okay? All right, so that's a setup. Now let's actually talk about sine, cosine, tangent, these ratios. The sine of an angle is the ratio of the opposite side over the hypotenuse. So we're going to write for this right triangle, the sine of angle A is going to equal the opposite side, which is A, over the hypotenuse, which is C. So it's the sine is opposite over hypotenuse, A over C. If we're talking about from angle B, well, it's going to be opposite over hypotenuse. What is the opposite side for angle B? B over the hypotenuse, C. So it changes depending on which angle that you're talking about. So the sine of A is A over C. The sine of B is B over C. Okay? Hang with me here. This is going to, repetition will help you out a lot. The cosine is a different ratio. It's not, it is the adjacent side over the hypotenuse. Okay, so from the perspective of angle A, what is the adjacent side? The cosine of A is going to be adjacent over hypotenuse. Adjacent is B, and the hypotenuse is C. So the cosine of A is equal to B over C. It's actually the same as the sine of B. We'll explore that more and talk about that more as we go along. What is the cosine of angle B? Well, the adjacent side of angle B is A, and the hypotenuse is C. So you can see this now. The cosine of A is the same thing as the sine of B. The sine of A is A over C, so is the cosine of B. That pattern will happen every time. The ratio for tangent is opposite over adjacent. So the tangent of angle A, what is opposite angle A? A. What is little a? What is the adjacent to angle A? B. So the tangent of angle A is opposite over adjacent, side A over side B. The tangent of B, well, what is opposite of angle B? Side B. What's the adjacent? Angle A. So the tangents of these two angles are reciprocals of each other. That will happen every time too. We will not be taking the sine, cosine, and tangent in geometry of this 90-degree angle. We'll always be doing the other two angles that are less than 90 degrees. Okay, so that is sine, cosine, and tangent. Now, these ratios, opposite over adjacent, etc. Here is a easy way of remembering this. Okay, there's a story about an Indian princess that I'll tell you about later, but sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So this Indian princess named Sohcahtoa, I'll tell you the story later, but remembering that name, Sohcahtoa, Sohchachtoa, will help you to remember, that sine is opposite over adjacent, SOH. Cosine is adjacent over hypotenuse. I said that wrong. Sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. So SOH, CAH, TOA. That word will help you to remember this. So here's where this whole deal starts. I'm going to ask you to write these ratios. So example 1, what is the sine of P? Well, what is opposite of P? Sine is opposite over hypotenuse. So what side is opposite of the P? 15. What's adjacent to P? The 8. What's the hypotenuse? 17. From the perspective of angle Q, the opposite and adjacent change. For Q, the 8 is the opposite, 15 is the adjacent, the hypotenuse is the hypotenuse. So for the sine of angle P, which was opposite? 15 over the hypotenuse, which is 17. The cosine will be adjacent over the hypotenuse. So from the perspective of angle P, that would be 8 is adjacent over the hypotenuse, 8, 17. All we're doing here is writing these ratios. The tangent of P will be opposite over adjacent, TOA, so 15 over 8. You should always simplify and reduce these ratios once they're written. What about from the perspective of angle Q? Sine, SOH. Sine is equal to the opposite over hypotenuse, 8 over 17. The cosine is equal to the adjacent over the hypotenuse, 15 over 17. And then the tangent, TOA, opposite over adjacent, 8 over 15. So the initial and important part of this is just knowing how to write these ratios from those perspectives of those angles. Okay? That's half of the battle right here. So go ahead and see if you can express the ratios here for 1, 2, 3, and 4, these, the ones that I've written out for you. Pause the video and see what you can do. Remember, SOH, CAH, TOA. If you've sufficiently paused, hopefully you've gotten these answers so far. When you did number 3, the sine of x, you should have had 2 over 4. That reduces to 1 over 2. So always do the reducing. Same thing there for cosine of x. The tangent, oh man, we had a square root of 3 in the bottom, so you have to get rid of that square root of 3. So you simplify those things the same way that you always do. And then did you see how on number 4, it's going to be simplified? 8's canceled, you have a square root on the bottom, get rid of it. Okay, you may have some questions. I'll be happy to answer those. The other piece of this concept guide, there's another piece that we'll add to this later. Your calculator has a sine, cosine, and tangent button. You've probably seen them. They say SIN, COS, TAN. Those are the abbreviations. So you can approximate these ratios by, if you know what an angle measure is, by saying the tangent of 15 degrees is what? Just type that into your calculator, and you should get 0.2679, etc. We're going to round these things to 4 digits, the 10,000 digit. All right? So if you didn't get 0.2679, you're probably in radian mode. Hit the mode button on your calculator and change it to degree. Everything that we're going to do in this class is in degrees. So you should have no problem then typing in COS of 60, enter, and gotten 0.5. See if you can get the sine of 15, the cosine of 75 as well. Hey, did you notice that they're the same? There's a reason for that. 15 degrees and 75 degrees are complements, so they would be, if there's 90 degrees, 90 degrees, 15 and 75 would be the three angles. So the sine ratio and the cosine ratio of the opposite angles are equal. Okay? So now, how do we use that calculator stuff? Well, we can solve, if we know a side and we know an angle, we can solve for the other sides. Let me show you how that works. So here in this triangle, we know that this side, CB, is equal to 7. We know that this angle here is 65 degrees. We're trying to figure out what x is. Well, what ratio does 7 and x have from the perspective of 65 degrees? If you'd rather, we can use the other angle, which would be 25 degrees. Let's start off with the 65. The tangent, opposite and adjacent, of 65 is equal to 7 over x. Or we could use the tangent using the opposite and adjacent of 25 is equal to x over 7. So you can use either one of those ratios to solve. Type in your calculator, tangent of 65, you should get 2.1445 equals 7 over x. We've got to get this x off the denominator. So you'd multiply both sides by x. That cancels it out over here on the right, and we have 2.1445x equals 7. Divide, and you get that x is approximately equal to 3.3. If you do it on the other one of them, you'll get the same thing, but you'd be multiplying 7 times 0.4663. So, in other words, we use the tangent ratio, or sine or cosine, to write an equation. That's what this is, y'all. This is an equation, tangent of 65 equals 7 over x. And you solve. The other example I have over here. All right, we got that this is 38 degrees. From the perspective of 38, x is opposite, y is adjacent, 84 is a hypotenuse. So for solving for x, we would want to use opposite and hypotenuse. Which ratio is that? Opposite hypotenuse, that's the sine. So we'd use the sine of 38 degrees equals opposite x over the hypotenuse, 84. Type in your calculator and get x by itself. Here's how I decided to use this one. I multiplied both sides by 84 to get the x by itself. And so I'm saying 84 times the sine of 38 equals x. You can just type that into your calculator, and you'd get approximately 51.7. To solve for y, we're going to use cosine because it's adjacent. So cosine of 38 equals y over 84. Exact same process. Y ends up equaling about 66.2. So what you're doing here is write the ratio. So right here on number 9, I'll help you get started. This is going to be which ratio? 37 degrees, x is opposite, 25 is adjacent. Opposite and adjacent, which one is that? Write your ratio. Okay, and then solve for your x. Okay, the code word here on this one is I have to see work here on 9, 10, 11. You're not in a place where you can do these in your head or even without writing stuff out. So write it out. See what answers you get. Do your very best. Here are the answers, though. If I just see those answers, I'll know you've cheated. Okay, get some rest. Have a good day. Bye.